Okay, so today we're going to be graphing rational functions. We're basically going to be putting together a couple of my other videos where one, I show you how to find the information for the rational function, and then the second part where you actually use that information to graph them. So today we're actually going to be putting those two pieces together and doing it all at one time. So it'll be a practice of actually finding the information and then applying it to graph a rational function. Okay, so I have this rational function. I need to first find all the information that I need to graph it. Okay, by using an acronym that I use with my students called TBB0, top, bottom, both, and then 0. So we start with the top of my rational function. The top of my rational function gives me my x-intercepts. So the top, the solutions, you set this equal to 0, and then those solutions are your x-intercepts. So when you get this solution of 7, that means I have an x-intercept at 7, 0, and another one at negative 8, 0. Okay? Then the bottom tell me my vertical asymptotes. So the solutions of the bottom, you set the bottom equal to 0, and those solutions of x equals 5 and x equals negative 4 are my vertical asymptotes. Both gives you your horizontal asymptote, and what that means is you compare the powers of the both. So if you actually multiply this out, you would get 4x squared on top, and then some stuff, and then at the bottom it's going to be x squared. Then you take the highest power of the top and the bottom and you compare them. Since they're the same, your horizontal asymptote is going to be the coefficients from the top and the bottom. So y equals 4. And then the last part is when you plug in 0. So to find the y-intercept, you find f of 0. So you got 4 times negative 7 times 8 over negative 5 times 4. And we'll do some simplifying first. 4 divided by 4. So you get positive 7 times 8. And then over 5. So your y-intercept is going to be 0 and 56 over 5, that's approximately 11.2, but we're going to leave it as 56 over 5 because we want to use exact numbers. Okay, so now we're going to use all this information to graph my rational function. So start with my vertical asymptotes. My vertical asymptotes are at negative 4, positive 5, then my horizontal asymptote, is at 4, positive 4, which is right here. Then my x-intercepts are at negative 8, positive 7, right there and there. And my y-intercept is at 0 and basically 11.2, which is basically up here. Okay? Now, we need to graph 3 pieces. Since we have 2 vertical asymptotes, we're going to have 3 pieces. So on the left, we're going to have one on this side, one in between, and one on the right. Okay? Now, having these x-intercepts here at negative 8 and 7, let me know that I have to come up here, cross through, and then follow my asymptote out that way. Same thing on the right side. Comes up, crosses, follows. Because a function will always follow its asymptotes. It can't cross its vertical, but it follows the horizontal and the vertical. So it follows them up and crosses. Now we know that these cross here because our roots are power 1. So since the multiplicity is 1, they will cross the x-axis. Okay. Now the middle piece, again, we have these vertical asymptotes that they can't cross. We have a horizontal asymptote here, and we have this x-intercept. There's none here, so we cannot cross this x-axis or these verticals. So the only option it has is to come down and then go back up. Now, since my y-intercept's way up here, that means it probably comes down like this and then goes back up like that, okay? Now, it could do a number of things. I mean, it very well could come down this way, come down, and then come back up like that, okay? But we're just talking about its general shape of these rational functions to get an idea of what it looks like, okay? All right, let's look at the next one. We're going to do the same thing. We're going to first start off by finding all the information that I need to know, okay? So again, start with the top, which is my x-intercepts. So I have one at x equals, I almost made the same mistake that some of my students make. It's an x-intercept, so it's at 0, 0, should be coordinates, and 6, 0. Okay? The bottom is going to be x equals 4, x equals 1, and x equals negative 4. That's my bottom, give me my vertical asymptotes. Horizontal asymptote. Again, you compare the powers of the top, which is squared, and the bottom is cubed, so it's bigger on bottom, which means y equals 0 is where my horizontal is. And because I already know I have a 0, 0 as an x-intercept, I know that my y-intercept also has to be 0, 0. Okay? I mean, you could plug in f of 0, okay, but at the top, you're going to see you can get 0 times negative 6, and on the bottom, you're going to get negative 4 times negative 1 times 4, and you're going to get 0 over something, which means automatically it's 0, 0, because anything divided by 0 will always be 0. Or 0 divided by any number other than 0 will be 0. So here we go. Let's draw our information. So again, start with my vertical asymptotes. I have one at negative 4, one at positive 1, and one at positive 4. My horizontal is at 0. My x-intercepts are at 0, 0, and 6, 0. All right. Now, since I don't have since my horizontal is at 0, and I only have 2 x-intercepts and they're not in the same area, I'm going to have to do a little extra work on this one because I have to actually plug in values into my function to find out if it's on the positive side or the negative side. So on this left side, we have 2 options. It either looks like this, or it looks like this. And we know it can't cross the x-axis because there's no x-intercepts, so we got to figure out which pattern does it follow. And the only way to figure that out is by plugging in a point and seeing if that point's on the negative side or if it's on the positive side. So I'm going to say, okay, I'm going to plug in x equals negative 10. If x equals negative 10, that means the factor on top are going to be negative and negative. And then the factors on the bottom are going to be negative, negative, and negative. And positive, because negative divided by negative, negative divided by negative, and we're left with just one negative. So this is net negative. So at negative 10, I'm on the negative side. So that shows me that I go like this for this one, on the negative side. Now I'm going to do the same thing for positive 10. If I plug in positive 10, I'm going to get positive, positive on top, positive, positive, positive on the bottom, so it nets positive. So on this side, on 10, I'm on the positive side. Well, since I have this x-intercept, and I know that this x-intercept crosses the x-axis, and I know at 10 it's on the positive side, I know that it's got to do this. It's got to come from the negative side, cross over onto the positive side, and then look like that. Okay? Now, if we had plugged in 5, you would have seen that we get a negative number. So we would have done on this side negative, on that side positive, which means we cross this from positive to negative. But because I know that this is power 1 from this root right here, I know that it crosses. So the only way it's on the positive side if it was on the negative side on the other side of the root. So just using some powers of deduction can help us find these. Okay? Now the middle 2 pieces. So I'm going to plug in for here 2. So when x equals 2, look at my factors. I'm going to get a positive and negative on top, then negative, positive, positive. And again, negative and negative divides to a positive. So we have positive or positive. So here on the positive side, which means since there's no x-intercept and it can't cross, it comes down here and then goes back up. And then lastly, I'm going to plug in -2. So x equals -2. And then I get a negative and negative on top. Negative, negative, positive on the bottom. So net's positive. So here we're on this side at -2. And again, if this 0 right here is power 1, which means it crosses, and these two connect, it has to cross like that. And that gives you your rational function. Now, most of the time when you're dealing with these rational functions, you'll notice, and of course there is no always or never in mathematics, but if you notice how this one on this side of the asymptote goes down, and on this side it goes up, and on this side it goes down, and this side's up, this side's up, this side's down. Usually there's that play where they go in opposite directions. If one's going to negative infinity, and the other side is going to positive infinity. Now again, that does not always happen, but most of the time it works that way. All right, so the next practice problem. Here we go. Again, following TBB0. Okay, so the top, the 0 is on my top. Now this -9 is not a factor, so I don't have to worry about it. So my x-intercepts are at +2 and -5. Okay, my vertical asymptotes. Now this is a tricky one because this factor right here is not fully factored. Okay, so I'm going to fully factor this. There's a greatest common factor of 3 there, so I'm going to pull that 3 out, x minus 3 and x plus 6. So you could see that if you just sat here and just took this and said, okay, then my vertical asymptote's at +9, you would be incorrect. My vertical asymptotes are actually at +3 and x equals -6. So be very, very careful, okay? Especially if these are not fully factored or you have to factor them, that you factor them correctly so that you can find your asymptotes and your x-intercepts correctly. Now, my horizontal asymptote comes from comparing both. So -9, so the top, if you multiply it out, will give you -9x squared, blah, 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 blah. And the highest power on the bottom will give you 3x squared, blah, 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 blah. But I'm just worried about these positive, or the powers being the same, and we use the coefficient, so we get -9/3. So that means y equals -3 is my horizontal asymptote. And then lastly, plugging in 0, we plug in 0, we get -9 times -2 times 5 over, that would be -9 times 6. Okay, and then you can see really quickly, -9 and -9 will divide out, and that leaves you with just -10/6, which reduces down to -5/3. Okay, so 0, -5/3. Okay, so here we go. Start with, again, with our vertical asymptotes, which are at -6. And +3. Horizontal at -3. Now my intercepts at -5, +2, and my y-intercept is -5/3. So basically that is 1 2/3. So it's somewhere between -1 and -2. Okay. Now we have three pieces to graph. So let's start on the left and the right. Now, again, you have two possibilities. Either it comes down and crosses the x-axis and follows it out, or it comes up and it follows the horizontal asymptote. Now, I don't have any x-intercepts, so it comes up, follows it out like that. Same thing on the other side. There are no x-intercepts, so it has to be on the bottom below the horizontal asymptote. And now look at the middle there. All three of our points are in the middle. So just connecting these three dots, because they have to connect, if I just connect these 3 points and then keep going, shows me what the middle looks like that. And again, if this y-intercept hadn't been there, we would have had to plug in another point if we just had the other two. But since all three of them are there and we know the multiplicity on our roots are 1 and they have to cross, the only way this shape will form is if it's that way. So that one was really easy. We didn't even have to plug in any points. We just used what we know about the graph and our x-intercepts to help us graph it. And now our last one. Okay. So our x-intercepts, we have an x-intercept at -1, 0, +3, 0. Vertical asymptotes at x equals 0, x equals 1, x equals -5. Horizontal asymptote, the power on top is 2, the power on the bottom is 3, so we're automatically at y equals 0. And y-intercept, there is none, because right here I have a vertical asymptote at x equals 0, which means there's an asymptote on the y-axis. So since we draw that one first, I have a vertical asymptote there at 0, one at +1, at +1, and then one at -5. So there's my vertical asymptotes. My horizontal at 0. My x-intercepts are at -1 and 3. And now we have some work to do because we have to plug in some points to find out where this thing is going. So let's start on the left side. So again, x equals -10. And when I plug it in to my factors, I get negative, negative on top, negative, negative, negative on the bottom. So we're on the negative side. X equals 10. So positive, 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 positive. So at top is positive, like that. And then we're going to do x equals -2. We plug in -2, we get negative, negative on top, negative, negative, positive on bottom, which nets positive. So here we're at positive, which means it looks like that. And then here we're going to have to plug in 0.5, which means on top we get positive, negative, positive, negative, positive, which means at 0.5 it's on the positive side up here, which means it comes down, a really small little u comes down and up again. And that is graphing rational functions.